Hello everyone. Today we will talk about electric fields. In the previous lessons in 8.1 and 8.2, we were talking about electric charge. In electric charge, we talked about how energy or how charges can be generated, and also we talked about the types of charges, and we explained how the charges it will attract or it will repel each other. Today we will talk about electric fields, which it also depends on the charges. It depends on the type of the charges. We will see if there will be same charges, then what will happen? There will be a repulsion. Or if there will be two different charges, positive and negative, we will see how they will attract each other. Firstly, take a look on this picture. Okay, here as you can see, this girl, what it's happening to her hair, it's the hair it start to stand up. But explanation for this or why this is happening, it is here what she is doing, she is touching this dome of a scientist. His name was Van de Graaff. This scientist, he used this dome to generate electricity, to generate charges. Then this dome, it's able to generate 100,000 volts. But now when this girl, she's touching this dome, of course now the volts here, it's not 100,000 because this it's very dangerous. The amount of charges here, or the amount of electric current here, it's less than 0.00002 amperes. Okay, this amount of current, it's far too small to be dangerous. Now, once she touched the dome, why her hair it start to stand up? The explanation here, it will be, this dome, it generate charge or electricity. And as we know, in our bodies also we have electricity, we have charges. Now, the force of repulsion between, now when she will touch the dome, the electricity it will conduct to her body, so it will start going through her body. But here what will happen? There will be a force of repulsion. Why? Because the charge of her hair and her head, okay, they will be the same. So in this case, what will happen? They will start repel each other. What do you mean by it will start repel each other? Now the charges will start moving from the dome to her body, okay, by this direction, and the charges that are here on her hair, because they are the same, so they will start moving in to the opposite direction. Okay, so now in this case the hair will start standing up. If we want to explain this scientifically, we will say, if electric charges feel a force, then scientifically speaking, they are in an electric field. So there is an electric field around the dome and the girl. Now, what is happening here, explanation for this, or what happened. Now, because we have charges, okay, we have electric charges, that's mean there will be, whenever there will be electric charges, that's mean there will be electric field. Now, electric field pattern. If you will take a look on these diagrams, all of them, it has this arrow, it has these lines, and each line it has an arrow. Now, These arrows, these lines, the red lines, it shows the electric field. But as you can see here, we have different shapes of electric field. These shapes, it depends on the source of the charges. For example, here when it's circle, okay, also it will be as circle. Here, electric field between two opposite point charges, okay? Here we have negative, here we have positive. Two different points, two opposite points, okay? Then here in this case, here we have two parallel plates with opposite charges on them. Electric field, okay, the charges here we have positive and negative, but you need to focus on something which is the direction of arrows. If you will focus on the direction of arrows, you will see always the direction of electric field, always it starts from positive to the negative. See here, how is the direction? It's coming from this direction. What's this? Positive. Look at this one. How the lines are moving, or what is the direction of arrows? This is the direction. It's coming from positive to negative. Also the same thing, it's here. It's coming from positive to negative. So the electric field direction, always it is from the positive direction to the negative direction. Okay, positive charge to negative charge. Curves, points, and ions. Take a look on these two diagrams. Here, as you can see, what do we have? We have two kind of conductors, okay? When these conductors are charged up, what will happen? The charges, it will start ripple each other. When they will start, these charges ripple each other, they will line on the outside, or on the outside edge, okay? Here, this one and also this one. Now, if you will look at the arrows, okay, this is what they mean by electric field. This is the electric field. But take a look on the arrows, you will see the space or the distance between two arrows, it differ from the previous and next one. As you can see here, let's say the distance here, for example, it is 5 centimeters. But as much as you will go up until you will reach here, see what happened to the distance between two charts. Here, now it will be less. Now, how this it will affect? When the charges are most concentrated near the sharpest curve, okay? So here it's curve, but this at this point, the curve will be sharp. So the charges, most of them will concentrate near this sharp end, okay? Look at the charges here. See, at this small point, we have, for example, 4 charges. Look at this small point. Also, we have like 4 or 5 charges. So, if you have a question now, it says where the electric field, it will be stronger. At which point? So, your answer will be at the sharp end of this conductor. Okay. Now, the electric field, it's written electric field strongest here at this point. The same thing it's here. Okay. Also, if you will have a question now, it says where the electric field will be, the strongest electric field will be at which part. You should point at this part. Why? Because this part it has a sharp edge. Then one more thing. Here it's talking about ions. In sharp spikes, if a sharp spike is put on the dome of the Van de Graaff generator, so let's go back to this one. This ball, when it's rotating, that means we said it will generate charges. If you will put any metal with a pointed tip, okay, next or close to the this dome, what will happen? Here now there will be charges, and if you will put a metal with a sharp end, now what will happen? These charges from dome will transfer to the metal, to the end, to the sharp end of the metal. Why? Because at the end, at the tip of it, of the metal, at the sharp end, there will be a high concentration of charges. So in this case, what will happen? Two different charges. And because they are two different charges, so they will attract each other. Another example, which is thunder, okay? Thunderstorm. Why thunderstorm it will happen or it will form? Thunderstorm, it form, as you know, when the clouds are, it contains charges. So what will happen? There will be attraction between the charges of different clouds, and then it will form like a spark. But why we can see this spark? It reaches until it reaches the earth. It started from clouds and it reached the earth. This spark, to reach the earth, that means there should be something in the air that it will carry this charge. Okay, what is the thing that it will carry charge through the air? It is the ions. What do you mean by ion? Here, look at this diagram. Here it shows the air. Air, as we know, is a mixture of different gases. Air is mainly a mixture of nitrogen and oxygen molecules. When these atoms, it will lose or gain electron, now this atom will be ion, okay? When the amount of ion in the air will be high or it will increase, that's mean in this case the thunderstorm it will form and it will be able to reach the earth. What will happen? The spark, it will start from the clouds, then it will reach until the earth. Why? Because the air molecules between the cloud and the earth are charged, okay? It contains ions. Now, these atoms, when they are ions, sorry. So what will happen now? They will have the ability to gain or lose more ions. So because of this, now the thunderstorm, it will form. Questions. Question number 1. The diagram on the right shows electric field lines around a charged metal sphere in air. Okay, you have this sphere, and as you can see here, you have positive charges. Okay. A, it says copy the diagram, draw in the direction of the electric field on each field line. Now, because this is positive, and to draw a electric field, we said you will draw arrows, and this, the direction of these arrows, it will be always from positive to negative. So where is the positive? Here. Where it will be the negative? Around it. Now, how the direction it will be? It will be in this way. Okay, from positive to negative. Here, in this way, it should be the direction of the arrows. B, if a positive charge were placed at X, okay, this is X. If positive charge were placed at X, in which direction would it move? Okay, now if you have here a positive charge, to which direction it will move? Okay, the direction here also, it will be away from sphere. Why? Because positive and positive, two same electric charge, what will happen to them? They will repel each other. So what will happen? It will start moving away from the sphere. C, if a negative charge were placed at X, in which direction would it move? Now here, instead of positive, it will be, we will say it will be negative. Now, if this it will be negative, to which direction it will move? Of course, it will move toward the sphere. Why? Because here you have positive and here you will have negative. Two different charges, they will attract each other. D. If a sharp spike were placed on the top of the sphere, okay, what would happen to the charge on the sphere? As we explained here, okay, in this explanation. Now you have this sphere and you will put a sharp spike, okay, on the top of the sphere. What would happen to the charge on the sphere? What will happen to the charges that are here? We said what will happen, as we explained here, always the charges, it will move toward the sharp end. Now, let's say here how many charges we have? 1, 2, 3, 4, 5, 6, 7, 8. Let's say you have 8 charges here. If you will put a spike here, now what will happen? These charges will start moving toward the spike and some of them will travel to the spike. Now, at the end, what will happen to the total number of these charges here? The number, it will be less. Why? Because these charges, it will flow through the through the point. Dear students, that was everything for this lesson. I hope you will get benefit from it. Please, when you will finish watching the video, write a comment, and if you have any question or suggestion, please text me. Thank you and have a good day.